Welcome back to week 1 discussion on naming organic compounds, in particular alkanes. Okay, now I did walk you through how to name a organic compound, okay, for a simple case. Let's step up the game a little bit. Let's go to the second one in line, C5H12. Okay, now all you have to remember is a compound with 5 carbon is pentane, right? That's the first thing you gotta first get it out of the way before you start, writing isomers and stuff like that and start naming them. All right. Now, as I've said, you gotta write, and I gave you this C5H12 is pentane on that long list of things I gave you. So we got CH3, CH2. You always write your general linear structure, the longest one, and I believe I got it right. And as I said, 5 carbon compound is pentane, but when we actually name it, we don't write just pentane, we write it as N-pentane. Now this is only for the longest chain, okay? You don't do this for any other derivative of that. All right, let me get a different pen now. Okay, all right, so N-pentane. So what's the next isomer or a derivative? Well, likely where we're going to start is 4 carbons, right? 1, 2, 3, 4, because we started with 5. And as I said, you cannot put your one remaining carbon on the terminal, right? So we can only put it here or here. They're both the same. You put it here or here, okay? Left to right or right to left. You can't do both, then it's identical. All right, so for now, I'm just going to put it here. And then I'm going to come back and fill it with different colors. So CH3, CH3, CH, CH2, CH3, right? That's my first derivative. Let's learn how to name this before we write additional structures. Okay, let me get a different color. Okay, perhaps a blue. Okay, so as I said, first your job is to start numbering. This is the problem. Okay, now if you had started with from left to right, I will show you that also. In this case, I've started from right to left. Don't worry about it, it's depending on where you want to put it. Okay, there is no set way to do this. In the last case, we looked at this. Okay, CH3, CH, CH3, CH3, right? If it is right in the middle, okay, and you have exactly identical groups, I'm going to get one more color here. In the previous case, not only it's right in this CH3 is right in the middle, but it's also surrounded on either side of this carbon by identical groups. Then it doesn't matter where you start numbering 1, 2, 3, 1, 2, 3, or 1, 2, 3. They both have the same meaning. In this case, that's not true. This CH3 is not only right in the middle, but this carbon is not surrounded by the same groups. On this side, you have, on this side, I thought I picked my blue. Maybe when I decide to do that, I guess it didn't. So on this side, you have okay. Okay. On this side, you have this group, which is an ethyl. On this side, you have a methyl. So it's not identical. So you cannot start numbering any way as you wish. You should always start numbering from the side, okay, that contains this methyl group, right? On this side of this carbon containing the methyl group, there's only 1 carbon. On this side, there are 2 carbons. So you should start numbering from the side that has the least number of carbons to the carbon to which this methyl group is attached. So that means I can only start numbering from this side. Okay, right? So this is incorrect. This is correct. I'm going to draw the incorrect version on what people do. This is the reason why I'm doing this video. Is I could have simply stand in front of a board and lectured, but it would be very difficult to find out where students make mistake. So let me get a different color. Okay, numbering this format is wrong. Okay, you should always start numbering from the side to which that methyl group is attached. This carbon is where this methyl group is attached. You look both sides, okay, and you start numbering from the side that has the least number of carbons on either side. And I quickly noticed that this carbon is the one that's least in number, so I started numbering from that. So we know that this group that's dangling off this long chain, okay, again you go get the long chain, okay, this is my long chain, and that is 4 carbons, right? 4 carbons. Any carbon compound containing 4 carbon is known as butane, right? So you come back and write butane, okay, and the CH3, as I have said earlier in my long list, CH3 is methyl. Okay, so that's methyl. Where is the methyl hanging from? It's hanging from the second spot right here, right? So it will be 2-methyl butane. That's the name of this. Okay, now let me recapture. How did I get this butane? Because I found the longest chain for this particular derivative, and that is 4 carbons, and 4 carbon is butane, 5 is pentane, 3 is propane, etc., 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 right? So that's why I got butane here, and this group right here is known as methyl, and so this is in the second spot. All right, let me complete the derivative with another case. Okay, so we're still on C5H12, right? And we did that 4 carbon version. Let's see if we can do a 3 carbon version, right? So 1, 2, 3, right? And I can't put my remainder 2 carbons on the terminals here, right? I can't put them here. Let me get a pen just to reinforce the idea. I can't put it here. I can only put it here, right? Okay, right? So let me go ahead and erase my X's, so we don't need that. Okay, let me get my pen back, and probably going to fill everything else with hydrogens now. So let me get my black pen back. Okay, so that means it's CH3, 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 CH3. Now you guessed it, okay, this is a perfect scenario, and probably the situation you probably all like. This is the carbon where these 2 methyl groups are hanging from, right? And if I look on either side of that carbon, we have identical groups, so it really doesn't matter where you start numbering from. So it will have to be, you can do it, this is identical on either side of this carbon right here, right? Right, so it doesn't matter which side you start numbering from. So I'm going to get my first pen to find out what my longest chain is. Well, my longest chain is 3 carbons, right? Again, you're only looking at the longest chain for the specific derivative, and it has 3 carbons, and we know 3 carbon, again all this will become really practice once you start doing few. 3 carbon means propane, right? So what do? You come back and write propane. That's your last name for this derivative, and we got to still get the first name, right? Okay, this is not also something we have done, which is we got 2 methyl groups, okay, and again it doesn't matter which side you start numbering. You can start numbering 1, 2, 3 or 1, 2, 3. It really doesn't matter, right? We do, however, know that there's 2 methyl groups on the second carbon, right? So there's only one way we can do this, is 2, comma, 2 prime. We call this prime in chemistry, okay? The one with the little apostrophe on top is called a prime, because both these methyl groups are on the same carbon. you have to give a distinction 2 prime hyphen. How many methyl groups are there? 2, and 2 in chemistry means di. 3 means tri, I guess not in chemistry but anywhere else. 4 means tetra. 5 means penta. We probably will never get to penta or any of those things, but you know, having it doesn't hurt, right? 6 means hexa, right? Since we got 2 methyl groups on the same carbon, it's 2 prime dimethyl. Okay, this is important. This right here is a methyl group, but there's 2 of them on the second. So this indicates the location, this indicates how many. Okay, this indicates the location. Okay, this indicates how many. And that obviously indicates what the nature of the group is. So let me write it in big terms. It's 2 prime dimethyl propane. Okay, how about I have you name this, something you already have drawn structural isomers for. So go ahead and draw the structural isomers and name each one of them. For C6H14, again I am tying back the same compound. I guess I'm not going to leave you alone until you get this right. So C7H16. So here's the questions I want you to do. Draw all possible isomers, and I think some of you have already done it. So all you have to do is probably redraw and name them, or you can use your existing drawings to and then name each of the isomer. Okay, I think based on what the information I have provided, I don't see any exception, but with chemistry you never say never. All right, so these are your 2 assignments. Go ahead and pause the video. All right, and then in the next video, I'm still debating whether I should do a separate video right away because I'm actually teaching this class on Friday, but I will definitely make a video giving answers for these 2 questions that I have here. All right, so go ahead and pause the video. First draw all possible isomer and then name each of the isomer. To do this, you may have to go back to the first video in this sequence where I did write what methane, methyl, butane, butyl, propane, propyl, etc., etc. All right. So, but let me just recapture what we have done. If your compound contains 3 carbons, okay, that's propane. Okay. Now this is if it is a straight chain, okay, for 3 carbons. Even if it is a derivative, the straight chain part, you only focus on the number of carbons. 4 carbons means butane. Okay, 5 carbons means pentane. Okay, 6 carbons means, you cannot apply this to what is hanging off the chain. This is only for the longest chain. Whenever, even for a derivative, when you identify a long chain, if it contains 3, 4, 5, 6, 7, 8, etc., then this is 6 carbons with the hexane. Okay. For the dangling ones, you may have to go back and get the list from the first video in the sequence. All right, you can pause the video and play with it and see where you're at. And if you have questions, ask me in class. For people on YouTube, you can just write me a comment, at least for this video, and I will post a different video for when I have it ready. All right, stay tuned.